What if the most groundbreaking discovery in human history wasn't something we stumbled upon, but something that had been waiting patiently for us all along? Picture this: a silent sentinel drifting in the frozen, multi-dimensional fabric of space, designed to awaken only when it detects a very specific signature, biological or technological, entering its range. This isn't science fiction anymore. Right now, astronomers and physicists are tracking an object that defies every law of traditional orbital mechanics. It's called 3I Atlas, and the data suggests something almost impossible. It wasn't just passing through our solar system, it was waiting for us. To grasp the magnitude of this anomaly, we have to understand the delicate cosmic choreography that governs the movement of stars, planets, and interstellar objects. When researchers calculated the velocity of 3I Atlas relative to the local standard of rest, the average motion of stars in our galactic neighborhood, the results were shocking. Most interstellar visitors, like the infamous Oumuamua or Borisov, blaze through our solar system at chaotic speeds of 26 to 32 kilometers per second, carrying the violent momentum of gravitational slingshots from distant dying stars. But 3I Atlas moved at less than 5 kilometers per second. In the vast theater of the Milky Way, it was nearly stationary. This isn't just unusual, it's unprecedented. To explain this, we must revisit a bold hypothesis proposed in 1960 by mathematician Ronald Bracewell. The Sentinel theory suggests that advanced civilizations wouldn't waste energy traveling at high speeds to every star. Instead, they would strategically place autonomous probes at gravitational equilibrium points, cosmic parking lots, and wait for stars to drift by. Our solar system, orbiting the galactic center at 220 kilometers per second, essentially floated right into its line of sight. But how would such a probe even detect us? Here, verified science provides the answer. While the sun's gravitational signature is subtle, its electromagnetic emissions act like a beacon. A sufficiently advanced probe wouldn't just detect light, it would scan for biosignatures, atmospheric imbalances like oxygen or methane, or even industrial pollutants that hint at a technological civilization. Humanity has been broadcasting its presence for nearly a century through radio, television, and radar. A probe positioned within 50 light-years could have detected our signals decades ago, but 3I Atlas's approach isn't random. Data simulations show it entered from above the ecliptic plane, coming from the constellation Ursa Major, offering a 6-week line of sight to Earth before reaching perihelion. This is no chaotic flyby. Its trajectory reads more like a reconnaissance mission than a wandering rock, and the most remarkable clue lies in its acceleration. NASA's Jet Propulsion Laboratory reported a simple radial push away from the Sun, but new, detailed analysis reveals a sideways component almost equal in strength, a tangential push that nature alone struggles to explain. Fluid dynamics teaches us that natural comets venting gas due to solar heating move unpredictably, tumbling randomly. But high-resolution images from the Hubble Space Telescope, carefully processed to remove glare, show 3 perfectly spaced mini-jets positioned exactly 120 degrees apart. This is no coincidence. The symmetry hints at intentional engineering, potentially directional thrusters generating precise transverse acceleration. A 2.6-kilometer object maintaining such geometric precision while spinning with a 7.1-hour period. This is the kind of behavior that marks an object operating under intelligent control, not the chaotic whims of nature. As we watch 3I Atlas drift closer, one thing becomes clear. It isn't just passing through the darkness, it's steering toward a specific destination, a trajectory calculated with incredible precision. And this is only the beginning. the predicted destination of 3I Atlas isn't arbitrary. On March 16, 2026, calculations show it will arrive at Jupiter's Hill radius with a precision of nearly 1 part in a million. In the realm of orbital mechanics, such pinpoint accuracy isn't natural, it's deliberate. But why Jupiter? Beyond being the largest planet in our solar system, Jupiter is a cosmic power station, a generator of immense magnetic energy. Its magnetic field is 20,000 times stronger than Earth's, sweeping through the charged plasma surrounding its moon Io, creating electrical currents measured in millions of amperes. If a probe has been waiting in the void for eons and needs to communicate across light years, it wouldn't rely on its limited onboard power. Instead, it could use Jupiter as an amplifier, injecting energy into the Io flux tube to modulate the planet's natural radio emissions, essentially broadcasting its presence to the stars. The implications are staggering. The velocity of 5 kilometers per second, the symmetrical 120-degree jets, and the precise targeting of the Jovian system aren't coincidences. They are parameters of a mission. If the Sentinel hypothesis is correct, humanity isn't discovering 3I Atlas. It has already discovered us. To fully understand, we must examine the contrast between chaos and intentional design. In natural comets, sublimation of ice produces irregular jets that cause unpredictable motion, a random stutter, as gas escapes into space. But telemetry from 3I Atlas paints a different picture. Its 3 mini-jets are symmetrically spaced at 120 degrees, producing a perfectly balanced transverse thrust. When applied in a coordinated, phase-locked sequence, this system generates a tangential push nearly equal to the radial acceleration away from the Sun. In short, this object isn't tumbling blindly. It's executing precise vector maneuvers. The forensic study of its rotational period reveals even more. While typical interstellar objects spin erratically due to solar torque, 3I Atlas maintains a rigid 7 one-hour rotation with its spin axis locked within 20 degrees of the sunward direction. This spin stabilization distributes mass evenly, preventing structural collapse, a level of mechanical integrity no natural comet could sustain over such rotations. Yet NASA's official reports continue to emphasize a radial-only acceleration, ignoring the complex sideways movement now confirmed by independent analysis. Even more striking is the presence of a sunward jet, or anti-tail, an ultra-rare feature that points directly toward the Sun rather than away. This could function as a solar sail or photon thruster, leveraging sunlight to produce momentum in a controlled direction. Combined with the release of specific isotopes detected by missions like JUICE, which show concentrations far above solar abundance, we might be observing a high-energy plasma engine at work. This isn't low-temperature sublimation. It's controlled isotopic engineering, a technology far beyond natural phenomena. With each passing day, 3I Atlas demonstrates active course correction. Its 3 mini-jets adjust its path by minute increments, sometimes half the radius of the Moon every 30 days, guiding it along a calculated trajectory toward Jupiter. Every micrometer per second squared of tangential acceleration is carefully applied, bypassing the chaotic forces of solar radiation, gravitational perturbations, and interplanetary dust. It's no longer a wandering rock, it's a sentinel navigating through our solar system with purpose. And yet, as it approaches its rendezvous, the question lingers: if this is an intelligent probe, what will happen when it reaches its target? Will it transmit data? Will it interact with Jupiter's immense magnetosphere to announce its presence? Or is it merely observing, patiently monitoring humanity's first detectable traces of advanced civilization? The stakes of this cosmic encounter are unprecedented. The most remarkable clue to 3I Atlas's nature lies in its internal structure and geometric precision. High-resolution imagery captured post-perihelion by the Hubble Space Telescope, carefully processed to remove glare from the nucleus, reveals 3 mini-jets arranged with exact 120-degree spacing around the object's equator. In the natural world, such symmetry across a 2-6-kilometer body is almost impossible. Comets venting gas under solar heat typically produce random asymmetric jets, resulting in unpredictable motion. Yet 3I Atlas defies this pattern. Its jets produce perfectly balanced transverse thrust, suggesting deliberate engineering rather than chaotic sublimation. Applying a theoretical lens inspired by physicist Michio Kaku, the 120-degree orientation is strikingly similar to a stabilization system that a Type 1 civilization might employ. By firing the jets in a coordinated, phase-lock sequence, the object generates a sideways push that complements the radial acceleration caused by the sun's heat. This means the tangential acceleration, observed nearly equal to the radial push, is not an accident. It's a controlled, vectorized maneuver. 3I Atlas is actively guiding itself, maintaining a stable, calculated course through our inner solar system. Equally compelling is the object's rotational period, the so-called 7-1-hour heartbeat. Unlike most interstellar bodies, which tumble unpredictably due to solar radiation torque, 3I Atlas spins with remarkable consistency, with its axis aligned within 20 degrees of the sunward direction. This spin stabilization distributes internal mass evenly, preserving structural integrity despite rotational stress. It's a level of design sophistication that suggests an object built to endure long-term travel, not a random aggregation of ice and rock. Further evidence points to advanced propulsion. The presence of an ultra-rare sunward-facing jet and anti-tail hints at the use of solar radiation pressure for directional control. By reflecting photons in specific patterns, the object could effectively sail through the solar system, adjusting its trajectory without relying solely on gravitational forces. The isotopic composition detected in the ejected material, notably nickel concentrations far above natural abundance, reinforces the idea of active engineering. If these elements interact with the solar wind, they could generate powerful particle fluxes capable of subtle manipulations or even long-range signaling. The picture emerging from the data is clear. 3I Atlas is not drifting aimlessly. Its 3 mini-jets, rotational stability, and carefully modulated isotopic emissions suggest an object designed for precision navigation. Each micrometer per second squared of acceleration is intentional, steering the body toward a specific destination. Natural physics cannot account for this degree of control. What we are witnessing is the interplay between the geometry of technology and the chaos of nature, a celestial sentinel exercising precise control in a system that typically rewards randomness. As 3I Atlas approaches Jupiter, the evidence for deliberate guidance only intensifies. Simulations show the object's trajectory targeting the planet's hill radius with an astonishing precision of 57 kilometers, a level of accuracy that natural phenomena cannot achieve. The radial acceleration reported in official databases understates the sophistication of its movement. The anti-sunward jets, combined with the spin-locked, symmetrical system of mini-thrusters, confirm an active course correction mechanism designed to navigate complex gravitational wells with microscopic adjustments. But why Jupiter? The answer lies in magnetospheric physics. Jupiter is more than a giant planet. It's a cosmic amplifier. Its magnetic field interacts with the plasma of Io's flux tube, generating enormous electrical currents. A probe waiting in interstellar space for eons could harness this natural energy to communicate across light years, modulating the planet's radio emissions to transmit data without expending its own limited power. This makes the Jovian system not just a waypoint, but a strategic objective, a communications hub for a sentinel probing the galaxy. In addition to magnetospheric advantage, 3I Atlas's precise inertial control adds further intrigue. The tangential acceleration we observe is applied consistently, bypassing unpredictable space weather and gravitational perturbations. Independent analysis confirms a calculated adjustment of its path by half the moon's radius every 30 days, a subtle maneuver invisible to traditional monitoring, but crucial for reaching a predetermined rendezvous. This is a level of precision that suggests intelligent design rather than the random forces governing comets and asteroids. Looking at the isotopic data, the presence of rare elements in concentrations far above natural levels points to high-energy processes within the nucleus. These are not accidental outgassings, they are deliberate emissions, possibly part of a propulsion system or signaling mechanism. The coordinated action of the three jets, combined with controlled isotopic release, is creating a system capable of precise navigation across interstellar distances, even using minute adjustments to correct its course. As we examine these parameters, one thing becomes increasingly evident. Humanity is not simply observing 3I Atlas. If the Sentinel hypothesis holds, this object has been observing us. Its trajectory, its emissions, and its symmetry all indicate a probe designed to detect, assess, and respond to signs of advanced life. Every broadcast we have sent from early radio signals to modern radar could have been intercepted, analyzed, and cataloged by a mechanism lying in wait for centuries. We are entering an era where the line between discovery and assessment blurs. The object is no longer a passive wanderer. It is an active participant in the solar system, responding to our existence with calculated precision. Its approach is a silent but undeniable handshake across the vastness of space, a testament to a level of intelligence and engineering that challenges everything we thought we knew about interstellar visitors. As 3I Atlas draws ever closer to Jupiter, the depth of its engineering becomes impossible to ignore. The symmetry of its three mini-jets, the measured tangential acceleration, and the spin-stabilized 7-1-hour rotational period all point to a body designed for precision and longevity. Every aspect of its behavior suggests an object capable of maintaining structural integrity while actively navigating the complex gravitational landscape of our solar system. Unlike a natural comet, which tumbles unpredictably, 3I Atlas moves with intention, adjusting its trajectory in minute increments that cumulatively achieve a remarkable level of control. Telemetry logs and simulations show that it adjusts its course by only micrometers per second squared of force, so subtle it would escape casual observation, yet consistent enough to steer it toward the exact location it was designed to reach. The precision targeting of Jupiter's Hill radius is not a chance encounter. It is a calculated objective, designed with the foresight to exploit the massive planet as both a waypoint and a communications amplifier. By modulating Io's plasma flux tube, 3I Atlas could potentially transmit information over interstellar distances without using its own limited energy. It is as if the probe has been waiting, patient for eons, silently observing, silently calculating, and now preparing to act with purpose. Beyond navigation, the isotopic composition of the ejected material provides a glimpse into potential high-energy propulsion systems. The rare nickel concentrations detected by missions like JUICE hint at a controlled plasma engine rather than simple solar heating. If these ions interact with the solar wind, they could produce detectable particle fluxes capable of influencing distant electronics or serving as a subtle signaling mechanism. Every measurement reinforces a single, inescapable conclusion: 3I Atlas is not natural. It is a sentinel, a relic or construct of an intelligence that predates our solar system. The implications for humanity are staggering. We are not just observing a cosmic anomaly, we are encountering a probe that has likely detected our civilization from afar, tracking our electromagnetic emissions and gravitational footprint. Its calculated approach transforms the concept of discovery into one of assessment. Humanity is no longer the passive observer of a wandering interstellar rock. Instead, we have become the object of observation, a data point in a cosmic experiment of a scale and sophistication that we can barely comprehend. Even more astonishing is the level of intentionality suggested by the object's trajectory. By the time it reaches Jupiter, every micro-adjustment made by 3I Atlas will have been executed with mathematical precision, a testament to the foresight and engineering of its creators. Its arrival isn't just an event. It is a message written in motion, a silent communication spanning light years, revealing not only advanced technology, but also the strategic intelligence behind its design. As the rendezvous with Jupiter approaches, the Sentinel hypothesis reaches its most compelling stage. 3I Atlas has transitioned from a mysterious drift to an object demonstrating undeniable, deliberate control. The lateral or tangential thrust observed is no longer subtle. It defines its path, guiding it with exacting precision across the solar system's chaotic forces. Every spin, every jet, every isotopic emission is a calculated move toward a predetermined goal. The mathematics of its journey speak to a level of intelligence capable of manipulating natural physics to achieve mission objectives. This is a turning point in human understanding. For centuries, we have studied comets, asteroids, and interstellar visitors as natural phenomena. 3I Atlas challenges that paradigm. It suggests that advanced civilizations, possibly Type 1 or Type 2 on the Kaku scale, may not simply explore the stars through brute force travel. They may strategically place sentinels, observing emerging civilizations, waiting until a system broadcasts its presence before initiating interaction. Humanity, through its technological emissions, may have unknowingly signaled its arrival on the galactic stage. The predicted intersection at Jupiter is more than a destination. It is a window into the intentions of a cosmic intelligence. The symmetry, the stability, and the precise navigation all converge to form a narrative of deliberation and calculation. By exploiting Jupiter's magnetic field and Io's plasma environment, 3I Atlas can amplify its presence, communicate, or simply observe. The object's controlled adjustments, previously imperceptible, now reveal a sophisticated understanding of orbital mechanics, fluid dynamics, and electromagnetics far beyond natural processes. If the Sentinel theory is correct, humanity's role is shifting. We are no longer mere observers of space. We are participants in a larger experiment. 3I Atlas has seen us, calculated our signals, and navigated toward a position that allows it to maximize observation or communication. Its journey is not random, it is purposeful. And as it enters the Jovian system, we stand on the threshold of potentially the most profound scientific revelation in history, an encounter that could redefine our understanding of life, intelligence, and technology in the universe. So, what happens next? Will 3I Atlas transmit its findings? Will it remain a silent observer, or will it interact with the Jovian environment to signal its creators? The truth is, we do not yet know. But one thing is certain: the precision, symmetry, and control we are witnessing cannot be ignored. Humanity is no longer simply discovering the cosmos has discovered us. If you've been captivated by this journey through space, science, and cosmic intelligence, make sure you hit that subscribe button, turn on notifications, and join us as we continue to track 3I, Atlas, and other interstellar mysteries. The universe is full of surprises, and this is just the beginning.